Welcome to my 9th tutoring session in A-level chemistry. In this video, I'll explain about shielding and shielding effect. In order to understand the concept of shielding, one should know the meaning of valence and core electrons. Let me explain the meaning of valence and core electrons using calcium atom as an example. Calcium atom has 20 protons in its nucleus, while the negatively charged electrons are arranged or distributed around the nucleus of the calcium atom in their respective shells or energy levels. You first come across the first shell or energy level that contains 2 electrons. This is followed by the second shell or energy level contains 8 electrons. This is followed by the third shell again containing 8 electrons. This is followed by the fourth shell containing 2 electrons. Now the electrons highlighted in the red color are the core electrons. Now core electrons are those electrons that are present in the inner shells. That is electrons present in shell 1, 2 and 3 of calcium atom. While the valence electrons are those electrons that are present in the outermost shell, which is also called as the valence shell. What is shielding? Shielding refers to the phenomenon where inner electrons, that is the core electrons, partially block the attraction between the positively charged protons in the nucleus and the outer electrons in an atom, that is referring to the valence electrons. Now in case of calcium atom, there are 18 core electrons and 2 valence electrons. Now the electrostatic force of attraction in the absence of core electrons is not blocked, while the presence of core electrons blocks the electrostatic force of attraction between the positively charged protons present in the nucleus of calcium atom and the valence electrons. Now each shell containing the core electrons act as a shield. So the shell 1 in case of calcium atom contains 2 core electrons and acts as shield 1. Shell 2 containing 8 electrons act as shield 2, and shell 3 containing 8 core electrons act as shield 3. Now these 3 shells act as shield and reduce the electrostatic force of attraction between the positively charged protons of the calcium atom present in the nucleus and the valence electron present in the outermost shell. So in case of calcium atom, the shielding is because of the core electrons present in the shells 1, 2 and 3, and these 3 shields reduce the or partially block the electrostatic force of attraction between the positively charged protons present in the nucleus of calcium atom and the valence electron present in the valence shell. Now in the presence of core electrons, the electrostatic attraction is blocked. Now let me explain the shielding in case of group 2 elements beryllium, magnesium and calcium. In case of beryllium, there are 2 core electrons present in the first shell. In case of magnesium, there are 10 core electrons present, while in case of calcium, there are a total of 18 core electrons. So therefore, there is less shielding in case of beryllium, moderate shielding in case of magnesium, and high shielding in case of calcium atom. As the number of energy levels or shells increases, there is a corresponding increase in shielding, and this reduces the effective nuclear charge and attraction. Now, the meaning and concept of effective nuclear charge will be discussed in my forthcoming tutoring sessions. Now, the shielding in group 2 elements beryllium, magnesium, calcium can also be visualized in terms of core electrons. As the number of core electron increases, the shielding also gradually increases. So therefore, you find less shielding in case of beryllium, moderate shielding in case of magnesium, and high shielding is seen in case of calcium. So as the number of energy levels or shells increase, there is increase in the number of electrons, and with the increase in the number of core electrons, there is increase in shielding, and finally, as a result, this reduces the electrostatic force of attraction between the positively charged protons present in the nucleus of calcium atom and the valence electrons present in the outermost shell. Finally, let me explain the shielding and shielding effect in case of group 2 elements beryllium, magnesium, and calcium. When moving down a group in the periodic table, that is, you're talking about the group 2 elements, what do you observe? You observe that the atomic number increases, that is, the positively charged protons present in the nucleus increases. So beryllium has 4 protons in its nucleus, magnesium has 12 protons in its nucleus, and calcium has 20 protons in its nucleus. So as you move down the group, the periodic table, you find that there is increase in the atomic number. And you also find an increase in the number of energy levels or shells. You find 2 shells in case of beryllium, 3 shells in case of magnesium, and 4 shells in case of calcium. Now the shells containing the core electrons act as a shield. So in case of beryllium, the first shell containing the core electrons act as a shield. In case of magnesium, it contains core electrons in shell number 1 and shell number 2. And therefore you find 2 shields in case of magnesium. While in case of calcium atom, you find a total of 18 core electrons present in shell number 1, 2, and 3. And therefore, there is a total of 3 shields in case of calcium atom. So with the increase in number of energy levels or shells, there is a increase in the number of core electrons. Each new energy level or shell adds more shielding between the outer electrons and the nucleus, and this leads to weaker attraction between them. And therefore you find less shielding in case of beryllium, moderate shielding in case of magnesium, and high shielding in case of calcium. And consequently, the ionization energy decreases down the group. So what is ionization energy? The ionization energy is the energy required to remove the electron from the valence shell of a particular atom. So the shielding effect, as I told you, also influences the ionization energy, which is the energy required to remove an electron from the atom. So greater shielding reduces the effective nuclear charge felt by the outermost electrons, and thereby making it easier to remove them. Now the meaning and concept of ionization energy and effective nuclear charge will be explained in detail in my next video. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.